Exercise 9.2, problem 1. Okay. Construct a segment of a circle on a given line segment AB equal to 5.2 centimeter containing an angle of 48 degrees. So we are given an segment, line segment AB is 5.2, and you'll have to construct a segment of the circle containing an angle of 48 degrees. Okay. It's pretty easy. So we'll just see a rough diagram. So this is your AB, okay, which is 5.2 centimeters in length. And this has to be, you have to draw a segment of circle on this given line. Okay, so this is a circle. So you'll have to draw a circle which touches both A and B, right? And this segment of the circle should contain an angle of 48 degrees. So you'll have to take any point on the circle, okay, and join that point. So in this case C, so join AC and BC, that angle must be 48 degrees. So that is what I mean. So this is the line segment, and this is the segment of the circle, and this segment of the circle contains 48 degrees. When they say contains 48 degrees, you take any point on that segment of the circle and connect them to A and B, okay, and in which case angle ACB will be 48 degrees. So even if you connect it here, right, it will be the same 48 degrees, or if you connect it here, okay, it will be the same 48 degrees. So this is what they say in this particular problem. Okay, there is a way to do this. Let's work it out. It's basically the tangent chord theorem we'll have to apply. Okay, let's start constructing. So draw a straight line AB of length 5.2 centimeters. Okay, then draw another line, right, which is at an angle of 48 degrees. So let's name it X. So we have to draw BAX, the angle BA, we have to draw it in such a way, angle BAX equal to 48 degrees, because this is what the segment they want. And we are trying to apply the tangent chord theorem. Okay, that's the background of it. Now you draw another line from AY, which is perpendicular to AX. Okay, so which means YAX is 90 degrees. So you are drawing a line AY, okay, which is perpendicular to AX, right? That is 90 degrees. Next, we'll have to find the midpoint of AB. So how will you find the midpoint of AB? From this point, which is, you know, take an arc and cut two arcs, one on the top, one on the bottom, from say with the same radius. From this particular point, you draw another arc, which will, and one on the top, one on the bottom, which will cut the previous arcs, and from that intersection points, join a line. Join the intersecting points. That is a perpendicular bisector of AB. Right. Now this perpendicular bisector will cut AY at one particular point. This is O, which is the center of the circle. So with O as a center and OA as a radius, or OB as a radius, draw a circle. Now you take any point on this circle on the larger segment, the largest circular segment of AB, any point C, and connect AC and BC. It will have the same 48 degrees. Why? According to tangent chord theorem. So this is a chord AB, and you're drawing a line tangent to the circle at that point, at one end of the chord. Okay, and this angle with the angle contained by the chord and the tangent is 48 degrees. So that angle will be the same, the circular segment will contain the same angle. So which means angle XAB will be equal to angle ABC, that is 48 degrees. Okay, so let me repeat. So with first draw a line AB of length 5.2 centimeter. Then you draw a line AX, okay, at an angle of 48 degrees to AB. Thereafter, you have to draw a line AY, which is perpendicular to AX. Okay, then you have to find the midpoint of AB. How will you find the midpoint of AB? Take a radius, actually, a radius which is greater than half the length. So in this 5.2, half is 2.6. So you can take 3 or 4 centimeters. With 4 centimeter radius, cut an arc on the above. With A as a center, cut one arc on above A and below A. Similarly, with the same radius of 4 centimeter, cut the previous arcs, one above, one below. Okay, with the same radius, and so this arcs will intersect at 2 points. So now you join the intersecting points, and that is a perpendicular bisector of AB. Now this perpendicular bisector will cut the line AY at one particular point, and that point is O. And with O as the center, OA or OB, OA and OB will be both equal. Okay, as a radius, draw a circle. Now this circle will have the same angle. This will contain the same angle, 48 degrees. So you can take any point on this line in the segment of the circle. Okay, let's say C. If you put it over here also and connect A and C and B and C, it will have the same for 48 degrees as per tangent chord theorem. You can measure it and you can check it out. Okay. Now let's list out the steps of construction. So draw a line segment AB equal to 5.2 centimeter. That was the first step which we did here. At A, make an angle BAX equal to 48 degrees. Draw a line BAX such that BAX is 48 degrees. Draw AY which is perpendicular to AY which is perpendicular to AX 90 degrees. Then draw a perpendicular bisector of AB. This is what we did by these two arcs, two sets of arcs. Then we draw the perpendicular bisector, and it will meet at O. And the perpendicular bisector meets AY at O. So this is the perpendicular bisector. This is the perpendicular bisector. It meets AY at O. And with O as a center and OB as a radius, okay, OA or OB both, draw a circle. So with OA or OB as a circle, radius, draw this circle. Take any point C on the alternate segment. This is the segment contained by the chord, right? So this is a segment, this is a chord AB. So this is the segment contained by the chord, and this is the alternate segment. So take any point in this alternate segment and join that point to A and B. So let's name that point as C, and you join the A to C and B to C. And as per the tangent chord theorem, the major arc ACB is the required segment containing the angle 48 degrees. If you measure that angle, it will be 48 degrees. So this arc ACB is the major arc which they are containing the 48 degrees. And this is what we are asked to draw. Okay, so I hope it's clear. If not, please go through one more time. It will become clear. Thanks for watching this video.